we're going to tackle multiplying and dividing integers right now. And we're going to take those together because remember, they always reverse each other, multiplying and dividing. So there are a lot of parallels. Usually, what's good for one is good for the other. A couple things here before we get into the nitty-gritty, just to review. When you multiply, and it doesn't have to necessarily be integers, but in multiplication in general, as far as how you write it, you can write it with what we would call the old-time multiplication symbol. You can write it with parentheses around the numbers, or with a dot in between. Probably the most preferred is the middle one with the parentheses. Really no question. If you have the dot, sometimes if you make it too big, it looks like a decimal point. This can start looking like a variable as we get into algebra now. So as I said, probably that middle one, you'll probably see that more and more. Division, again, just to review, you can have it with our old-time division sign, which actually means when you crank it out into long division, the first number is the dividend, it goes in the den, in the box. And you can also show it as a fraction. And you might not like this news, but as we go further and further into algebra, we're going to probably see that little notation a little bit more than our old-time division sign. So we'll try to mix it up, get you used to seeing all the different notations so that you're good for any occasion. All right, here we go. First up, positive times a positive. Your answer going to be a positive. That's just like it always has worked for you. In the case of 3 times 10 is 30, or 4 times 2 is 8. Okay, we're not going to reinvent the wheel. Keep that in mind. Even though now we have a negative times a negative, we're still going to end up with a positive answer here. A negative with a negative, in this case a negative 3 and a negative 10, in a sense going to hook up and make a positive number. Negative 4 and a negative 2, when they multiply, we're going to end up getting a positive 8. So when the signs are the same, we're going to end up with a positive result. Now, here's where you have to keep on your toes, maybe not so much as you have to with addition and subtraction. A positive times a negative, or a negative times a positive. Remember, multiplication is commutative, so it can go in either direction. Your final result is going to be negative. No questions asked. Not which do I have more of, what's the absolute value, which is a bigger team, none of that. It's just, you can now say it's always going to be like that. Addition and subtraction, you couldn't necessarily always use the word always. But here, a positive times a negative, no matter which case, in this case it's a negative times positive, your result will always be negative. So basically you just do it. 5 times 2 is 10, but then that little dash is hanging out there without a partner, going to have a negative. Positive times negative, 7 times 1. 7, but again, that little dash hanging out there, nobody to hook up with, it's going to carry over to the final answer. Negative 3 times negative 5 times 2, still, again, just do it. 5 times 3 times 2 gives you a 30. These two negatives are going to hook up, make a positive. Here, you're like, wait a minute, is that the same problem? Not quite. We changed it to a negative 2. And so we're still going to get a 30, because 3 times 5 times 2 didn't change, but now there'll be the odd man out. And so therefore, we're going to have a negative in our answer. Now, that's all well and good. Okay, a positive times a negative is negative, but there might be somebody out there thinking of this. The dreaded why question. Why is it? Why is a positive times a negative negative? Why is it not positive? Well, sometimes when things are by definition, you really can't argue with it. It's sort of like, why is this called a marker and not a dog? Because it's a marker. You might not like the word, but guess what? We're stuck with it. Sort of like, why is the sky blue, even though pink might be your favorite color? That's just how it is. But we're going to go through and maybe show you a little show, not quite necessarily a proof. Look at the pattern. 5 times 3, 15, we got it. 5 times 2, 10, just like the old days. 5 times 1, 5, and 5 times 0 is 0. But as, again, mathematicians love patterns, they love to try to explain the universe with patterns. Look what happens. The 5 stays constant. Our numbers keep going smaller here that we're multiplying by. and we go down by 5 each time. So when we would get to the 5 times 0 is 0. Now 5 times negative 1, it can't turn around and go back up and be a positive 5. It has to be a negative 5 because we want to continue that pattern. All right? So that's sort of a quick little why it has to be defined to be that way, that a positive times a negative is going to be a negative. Now we want to give equal time to division. And really, again, we talked about the rules being the same. You really basically just do it. You do the division, and then you can worry about the sign. 100 divided by 20 is 5. Right? They're both positives. You're good to go. Negative 100 divided by negative 20. Well, 100 divided by 20 is 5, and our final answer will be positive. The two negatives will hook up in a sense and make a positive. This last example up here, the fact that hey, it's still a 5, but it's going to be a negative 5 because one of the players is a negative. All it takes is for one different sign, and your answer will be negative. Now, here are 3 little examples here. Now, as we go through and try to anticipate, what do you think I'm going to be writing for an answer? Right? 14 divided by 7, negative 14 divided by a negative 7. Well, 14 divided by 7 is 2, and this will be a positive because the signs are both negative. 24 divided by 8, last time I checked was a 3. But don't go away yet. Hopefully you're thinking of a negative 3 for an answer. We have, again, right here, if you're going for the partial credit on this last one, think about it, negative 16 divided by 4. All right, hopefully you know your answer is going to be negative. And then 16 divided by 4, just like it always is a 4. Just takes that one odd man out that your answer will be a negative for multiplying and dividing. What's left to say? Well, we can sum it up in one word. Yep, you guessed it, practice. That's the only way that you will gain confidence as you go through and learn your, if you want to call them rules or procedures for dealing with operations, positive and negative numbers. Good luck.